Okay, finishing up hopefully the last section, 9.5, day 1. And in here we're still going to be integrating trig functions, but we're not going to use the reduction formulas today. We're going to come up with a couple of shortcuts for some special cases. So our first special case today, or the only special case we're going to talk about today, are integrating odd powers of sine and cosine. And we're not going to use those reduction formulas we've just been working with. Okay, I think I'm going to give you the steps to start with instead of at the end. So, if either your sine or your cosine in the integral has an odd exponent, these are the steps you're going to follow. First step is to take one sine or cosine from the odd exponent term and associate it with the dx. So just slide it over next to the dx. Then, that would mean if I started with an odd and I subtracted 1, now I'm down to an even power of sine or cosine. So, take the remaining even power and write it as a power of 2 raised to another power, and you'll see that when we get to it. Then use a Pythagorean identity and expand with Pascal's triangle, and that would come back. Then the last step is to distribute and integrate with your power rule. I know it sounds like a lot, but it's actually not bad. It's a little bit better than the reduction formulas, I think. Okay, so I'll take you through 4 examples today. So and each one's slightly different. So we will start with just having a sine or a cosine in the problem. So I'll start with a cosine to an odd power. Okay, the first thing we want to do is steal 1 from this and slide it over next to the dx. So that will leave cosine to the 6th here, and then the other cosine I know is going to get associated with the dx. Okay, take this remaining even power and write it as a power of 2. In other words, cosine to the 6th could be written as cosine squared raised to the 3rd power. Because remember, you'd multiply exponents here and you get 6. And then I still have my cosine x dx. And the reason I write it as cosine squared is now I can use my Pythagorean identity, sine squared plus cosine squared equals 1, and do the substitution. So in place of cosine squared, you should know by now that that is 1 minus sine squared. And that's what's still being cubed. So notice I'm going to have sines after I expand, and the derivative of sine is cosine, so I'll be able to do power rule later on here. Okay, so I'm cubing. So I know in Pascal's triangle when I cube this out, it's going to have those 4 terms in it. I think I'm going to back up over here. It's going to get a little bit long. My 4 terms. 1, 2, 3, 4. And then I still have my cosine x dx on the end. Okay? So my multipliers on that third row are 1, 3, 3, 1. And then my a term is just a 1. I'll have 1 to the third, 1 squared, 1 to the first. So I'm not even bothered with the 1 because that's not going to change anything. So my b term is this negative sine squared. So on the end, negative sine squared. I've got to cube that. Negative sine squared. Remember, we start with the 3 and then we decrease, so now I'm at the second power. Negative sine squared to the first power and then to the 0 power. Okay? Now, just to save a step, I'm going to be doing the powers and the distributing all at once. So now I'm just going to distribute, because I'm at the spot where I said use a Pythagorean identity to expand. Now I'm at distribute, and then I'll integrate. So distributing the cosine. So I have cosine x dx. This one. And I'm going to make separate integrals right now too. So the negative sign is to the first power, so I will have negative 3 integral of sine squared. And I think I'm going to write it like this, so you can see an inside-outside here. That's just this term here, with the negative pulled out in front, and then times my cosine x dx. Distribute again to this term. First I'm going to square, so my negative square becomes positive. My 3 is a multiplier. Notice the 3 is not square distance, so then I've got to square my sine square. This becomes sine to the 4th. And I'm going to write it like this, so I can see an inside to a power times the cosine. And then my last distribution is right here. I'll do the power first. I'll have a negative cubed. That's going to be negative. Integral, and there's a 1. So this becomes sine to the 6th. And then a cosine. X dx. Oh, that was 1. And now each one of these should be something that I can integrate very easily. Okay, the first one, there's no power rule needed. What has cosine as its derivative? Is sine. So I get sine x. Next one, minus. Now recognize this as an inside to a power. If I have the derivative of the inside, derivative of sine is cosine, attached to the dx, I can just do a power rule and throw this stuff away. So I'm going to add 1 to this and multiply by its reciprocal. So that'll be a 3. Now I'm just going to eliminate the parentheses again. Times 1/3 times 3 gives me a 1, so I don't even need anything there. Next one. Inside is sine, derivative is cosine. Every time it's going to work for us. So now I can just do the power rule. So add 1 there, I'm going to have a 5 and a 1/5. So that will give me 3/5 sine to the 5th. And then my last one, minus. Add 1, I get 7, I need a 1/7. Plus 3. Okay, let me check my answer, make sure I didn't make any mistakes. Sine minus, where am I at? Plus 3/5 minus 1/7. Sure enough, I got a mistake on this one. Where did I make the mistake at? Oh, in my notes here. Look at that. Double check that. Yeah, click 1. That should be sine squared to the first. Okay. My notes are wrong. This time I got it right. Okay, good. Next one. I will have cosine squared times sine to the 7th. Okay, even though I've got the cosine and the sine together, look to see if one of them is the odd exponent. If there is, I can follow the rule, the 4 steps we just did. I see the odd exponent is here on the sine. So what I'm going to do is, the first thing you do is you steal one of these, associate it with the dx, and then write this as that power of 2. So this is just going to carry along for the ride for a while. So cosine squared. This I'm going to bring down to sine to the 6th. And make this other sine to the 1st over here next to dx, so I still have sine to the 7th. This gets rewritten as a power of 2, so I can do a Pythagorean substitution. So this becomes sine squared to the 3rd power again, and then I got my sine x dx. Okay, now a Pythagorean substitution. That'll be 1 minus cosine squared. That still has to be cubed. Get my sine x. Expand this. This is going to carry along and get distributed along with the sine. So maybe I think I'm going to slide this over to here, and I'll do the expansion first. So I need my 4 terms. I'm just going to slide this cosine squared down to the end here. Put it next to the sine x dx. Pascal's 1331. Again, my leading term is a 1, 1, 1, 1. I don't need it. My negative cosine squared starts down here. That has to get cubed. Then negative cosine squared to the 2nd power. Negative cosine squared to the 1st power, and then nothing. Now I distribute, but take a look. I've got this whole thing to distribute. Well, and the dx to each one of these. And I'll write them all separately. So this first integral will be cosine squared x sine x dx. And I'm going to write the cosine squared this way so you can see the inside outside, do the power rule a little bit easier. Sine x. This next one, there's no squaring or anything here, no power, so it's just a negative 3, so minus 3 integral. But I've got a cosine squared here, and I'm multiplying by another cosine squared. That's going to give me cosine to the 4th. And then I still have the sine x. Okay, distributing here. I have to do the power first, then combine with this. So a negative squared is positive, 3. This will become cosine to the 4th. And when I multiply by a cosine squared, I add the exponent. So 4 plus the 2 is going to give me cosine to the 6th, not cosine to the 8th. I add exponents. And then the last one here, I'll have a negative cubed. That's going to be negative. This will be cosine to the 6th, multiplied by cosine squared. I add 6 plus 2 is going to give me 8. And then a sine x dx. Okay, each one of these should now be integrable, but with a power rule. So if I look, I've got an inside to a power. Derivative of the inside, derivative of cosine is actually negative sine, so I need to take